Now, back to the topic bases. I said all alkalis are bases, but not all bases are alkalis. All compounds with OH in the formula is a base because they are soluble base. They are alkalis, but not all bases are alkali because some bases form amphoteric oxides. They are amphoteric in nature. They are not soluble in water to form alkalis, so they are not alkalis. All alkalis are bases, but not all bases are alkali because there is a category of base called alkalis, but not all bases are soluble in water. Those that are soluble in water are called alkalis. Now, physical properties of bases. I said a base has a bitter taste. Actually, you are not supposed to taste it, but it has a bitter taste. Then it is soapy to touch. When you touch it, it's slippery. Then it turns red litmus paper blue, just like an acid turns blue litmus paper red. And concentrated forms of the two strong acid, the caustic alkali, that's sodium hydroxide, and the potassium hydroxide. Those two, they are very, very strong. Sodium hydroxide and potassium hydroxide, they are very, very strong. Their concentrated form are also corrosive, just like the concentrated form of acid are corrosive. So with this, we can move to the chemical properties of bases or alkalis. As we are describing base, we are also describing alkalis. What are the chemical properties? Number one, all bases react with acids to form salt and water. I'm going to give you an example. I'll use an alkali here. That's sodium hydroxide is an alkali. I'll also use an insoluble base, like a normal base. Then I'll use magnesium oxide too. That is a base that can dissolve in water to form magnesium hydroxide. Now, this one is not soluble, it's amphoteric. Now, it reacts with an acid. Let me use hydrochloric acid as an example. Then here I'll use trioxonitrate 5 acid, which is also a very strong acid. And here I'll use tetraoxosulfate 6 acid. I can even use tetraoxosulfate 6 acid here. And then here I'll use I'll use hydrochloric acid. Now, to write the equation of reaction, we'll split the ions. I'm describing neutralization reaction between acid and base. Now, sodium has +1, OH has hydroxide -1, hydrogen has +1, tetraoxosulfate 6 ion has -2. These are radicals that you're expected to know, that I referred you to. So with this combining with that, positive ion combining with negative ion, there is an exchange of radicals. So you end up having Na2SO4. The one from sodium is invisible. The minus from SO4 is invisible. Just the 2 will go down. Then H and OH becomes water. The same also. So this is a salt from sodium tetraoxosulfate 6 and water. Acid reacts with base to form salt and water. The same thing also occurs. You have NO3 minus. Then we have copper +2. Then oxygen -2. Copper combined with NO3. There's an exchange of radical. There is a -1 here, which is 1. The 2 covers NO3, and then you have NO3 from copper. From the 2 from copper going here, then the 1 from NO3 is here, which is invisible. And then you have H and O left, which is H2O. Just try to balance the equation. Then the last one here is magnesium oxide. We have magnesium oxide and O2 minus. Then we have H and Cl. I'm going to be very fast now so that we can make up. This will give you, by exchanging their valency, magnesium chloride and H2O. Because of the hydrogen and oxygen left, there is an exchange of valency. 2 goes to chloride, -1 from chloride goes to Mg, which is invisible. the signs are invisible. So this is salt and this is water. This is salt and water. This is salt and water. That is neutralization reaction. That's the first chemical property of a base. The second property is the major test for a base. A base can react with any ammonium salt. A very good example of an ammonium salt is ammonium chloride. Don't forget, bases can be oxide or metallic oxide or hydroxide of a metal. Metallic oxide or hydroxide. And another example of base I did not mention, which is like is a gas naturally, is ammonia gas. Alright, we'll get to know this when I explain this. This is an ammonium salt. You can also use ammonium nitrate. When it reacts with any base, there will be a libration of ammonia gas. Excuse me, I'm going to use this. Now, when you want to react this NH4 plus 1 from NH4, then Cl minus 1. This one carries plus 2 from the atomic number, which is 20, and OH carries minus 1. Bring this together, then this together, positive, negative. So, on bringing this together, positive combined with negative, excuse me, let me use this. So we have ammonium hydroxide, plus and minus of ammonium and hydroxide cancel out. You have NH4 OH, and you have calcium chloride. That's Ca2 plus and Cl minus, exchange their valencies. You have this. Now this is like ammonia in water. It's ammonia gas plus H2O. Remove H from here, add it to this one, that's H2O, plus this salt. So it's better written as CaCl2 plus H2O plus ammonia is a gas. So this is a major test for a base. When a base reacts with ammonium salt, this is a base, it will liberate ammonia gas, which has a foul smell, a pungent smell like that of a urine. The same thing happens here. You end up getting NaNO3, NH3, and H2O. Because of our time, I won't be able to solve this. So learn and read up on